Every year, industries that drive the U.S. economy release billions of tons of carbon dioxide into the atmosphere. These industries include fossil fuel power plants, as well as industries that produce ethanol, oil and gas, iron and steel, cement, and chemicals. Capturing and using this CO2 instead of releasing it is an exciting opportunity for energy, economic, and environmental security in America.
CO2 is a remarkable fluid. It can be injected into depleted oil fields to produce oil that otherwise would have remained in the ground. The United States has produced more than 1 billion additional barrels of oil doing just this already. And it can be injected and stored in deep saline aquifers in the subsurface for a return of substantial tax credits, currently up to $50 per ton of CO2. Capturing and storing CO2 is great for our energy security because it enhances underground energy extraction. It's also great for economic security because it increases industry revenues through government tax credits, improves industry competitiveness, and generates jobs. And it's great for environmental security because it reduces the carbon footprint for a whole range of industries. Capturing, transporting, and storing CO2 has many benefits, but realizing these opportunities requires building new infrastructure on a massive scale, including constructing a vast network of dedicated pipelines connecting CO2 sources with storage sites. These infrastructure decisions are very expensive, tens or hundreds of billions of dollars, and these decisions are very complex. That is where our software, SimCCS, comes in. Los Alamos National Lab has collaborated with Indiana University and Montana State University to develop SimCCS, a new and powerful open source software that will help make large-scale CO2 capture and storage a reality.
SimCCS is a free and customizable software that does things that no other CO2 capture and storage software does. First, it's the only software to address simultaneously all critical infrastructure decisions and their risks, such as where, how, and when to capture, transport, and store CO2. It also accounts for tax credits and energy production.
And second, SimCCS is the only software that can run on any desktop computer, on the internet through a science gateway, or using high-performance computing. And finally, it's the only software that generates realistic, large-scale pipeline networks that are essential for CO2 capture and storage, and finds low-cost corridors through complex geographies like steep topography and sensitive Native American land.
Overall, this software enables industry and government to design optimized CO2 capture and storage infrastructure, including the necessary large pipeline networks with trunk lines.
These infrastructure solutions simultaneously optimize capture, transport, and storage decisions, and allow users to both minimize infrastructure costs and carbon footprints, while maximizing revenues through tax credits and enhanced oil production.
The SimCCS software is already supporting industry, government, and other institutional efforts to understand the broad impacts of carbon capture, transport, and storage on a large scale. Major users include the US Department of Energy, the National Petroleum Council, major universities such as Stanford and Ohio State, industry including BP and Southern Company, and institutions such as the Great Plains Institute.
The Great Plains Institute is working with Los Alamos to use SimCCS to engage stakeholders across interest groups, from industry, government, and nonprofit organizations. The outputs from SimCCS are helping us to identify best opportunities to capturing CO2 emissions for both utilization and long-term storage throughout the U.S.
SimCCS is a game changer. It's the only software that can help decision makers manage CO2 capture, transport, and storage on a massive scale, and make it a reality in the United States and beyond.